Dear students, today we have to read the magnetic field due to a straight solenoid. So what do you mean by solenoid? This is an insulated cylinder. This is an insulated cylinder. And upon this insulated cylinder, an insulated wire is wound over it, just like a number of rounds, and these two terminals are connected with a battery with the help of key K. When the key is on, then charge is flow from positive towards the negative terminal of the battery continuously. The entire structure is called as solenoid. But as we know, a conductor carrying current is create a magnetic field around it. Similarly, each and every point of the conductor create the magnetic field around it. For example, this is the wound of the wire. Here, this point, this point, this point, this point, this point, all the points are created a number of magnetic field. But inside the solenoid, all the magnetic lines of forces are parallel. Why? If this is a bar magnet, North Pole and South Pole, from North Pole to South Pole, number of lines of force are goes, but inside the magnet south to north. So inside the solenoid, all the lines of force are parallel, and outside it they are bent or curved like structure. And hence we can say inside the solenoid, all the magnetic lines of force are parallel, and outside it is bent, because a solenoid behaves as a magnetic dipole. Now this is a diagram of magnetic field with one wire. Number of wires in the magnetic field gote wire kon asibo ei type asibo. Here we give dot sign and here we give a cross sign. So what do you mean by dot and cross? You see, current is this is the solenoid. Solenoid ro current kon hochi imiti bulliki imiti athre bhitru use current imiti cyclic manner re se asu. Jetholgi imiti asu kodu asu towards out of the plane of paper. In the bhitru bulla athre kodu hochi towards the inward of the plane of the paper. Always the current which is inward the plane of the paper is represented by cross signs. It is cross sign द्वारा represent करा होची. current इमिति आसिला इमिति आसी ये inward भितरु होची ये ला cross sign. इडी कोन होची current बाहर को इन बाहर किन बुली जाउची. ई point को denote करा जाय कोन dot, and this is a cross. And in this figure, current is like this in the बुलची जुरे की हमें आउटवर्ड एड बाहर करंट बाहर लाडू हमें कोन दवा क्रॉस साइन, बिकॉज इट इज आउटवर्ड. इट कोन होची ना भितरु करंट जाउची, इट इज डिनोटेड बाय डॉट साइन. दिस इज द सिंपल स्ट्रक्चर ऑफ magnetic field with one wire. Similarly, if two wires are there, this is the magnetic field with two wires. This is first wire and this is second wire. But in this case what happen, the tangent upon the lines of force gives the direction of magnetic field. In this case, this is the direction of magnetic field. But these two fields are equal in magnitude and opposite in direction, and hence they are cancelled to each other. So outside the solenoid, the magnetic field is always 0, and all are understanding for solenoid. All are. Now we have to discuss how a magnetic field is created by a solenoid. This is the cross section of a solenoid. Here you see a number of cross denotes inward. एमती आसूची करंट एमती भीतर बस फर्स्ट रिंग, देन एमती गला बाहरला, एमती सेकेंड रिंग, एमती थर्ड रिंग, एमती फोर्थ रिंग. So a solenoid is an insulating copper wire wound closely in the form of helix on a round and its length is very large as compared to its diameter. When current is passed through the solenoid, then each turn of the solenoid can be regarded as a circular loop carrying currents and thus will be producing a magnetic field. The total magnetic field is the vector sum of the magnetic fields due to currents through all turns in the solenoid. Our magnetic field in Gottaker magnetic field, second magnetic field, third magnetic field. Their sum is known as the total magnetic field. So let us consider this is a solenoid. Dot hଉଛି ତମର outward, crossed ହଉଛି crossed ହଉଛି inward, ଭିତରକୁ ଯିବ, dot ହଉଛି outward. Let us consider a solenoid consists of n number of turns per unit length. Be the amount of current flowing through the solenoid as shown below. ଏଠି କ'ଣ ଆମେ ନେଲେ, ମନେକର L length रे I amount of current flow ही जाଉଛି. At various turns, this is first turn, second turn, third turn. At various turns of the solenoid, current comes out of the plane of paper, is pointed by dot mark, and enters into the plane of the paper is denoted by cross mark. To determine the magnetic field B at any point P, let us consider a closed loop A, B, C, D. A, B, C, D is known as empyrean loop of length L at the middle of the solenoid. In middle of the solenoid कौन कले ये point P को surrounding करी उटे empyrean loop rectangular loop A, B, C, D हमें ले. Now, according to Ampere's circuitial law, surface integration of B dot dl is equal to mu 0 into total current in the loop A, B, C, D. According to Ampere's circuitial law, surface integration of B dot dl is equal to mu 0 into I. What is I? Total current. Or implies B dot dl equal to mu 0 into total current means number of turns A, B, C, D into current. ये भितर जितना टर्न रहा केते टर्न रहा मनकर गोटे टर्न अच्छी 1 into I, 2 turns 2 into I, n turns n into I. So n into I, what is the length taken? L. So total number of turns how much? N into L. This is first round, second round. In the L pante number of turns multiplied by length multiplied by current in each turn. So surface integration of B dot dl equal to mu 0 into Ln into I. Give it equation 1. Now surface integration of B dot dl equal to surface integration of A to B B dl, B to C B dl, C to D BDL, D to A, BDL. You see, A to B, B to C, C to D, D to A. But C to D is situated outside the solenoid. So outside the solenoid magnetic field is 0. So this total term will be 0. Okay, A to B, B to C, C to and D to A. But D to A, this is the direction of magnetic field, and this is the current element DL, angle between them 90. This is the magnetic field, and this is the current element, angle between them is 90. So A to D pi angle is 90, B to C pi angle is 90, but from A to B angle is 0 because both DL and B are in same direction. So say for same direction we can put 0 degree. It is perpendicular 90, it is also perpendicular 90, cos 90 0 0. So surface integration of B dot DL equal to A to B BDL into 1. This is your equation 2. Now equating 1 and 2 we get BL is equal to mu 0 NL into I, or B equal to mu 0 N into I. This is the magnetic field due to whole of the solenoid. But what is an number of turns per unit length? आम पूराटा बाहर न करी एरिया बाहर कले नंबर ऑफ टर्न्स पर यूनिट लेंथ रे बाहर कली. So this B may be also written as mu 0 को mu 0. Instead of small n we can put n by L whole into I. This is the net magnetic induction due to a solenoid, number of turns per unit length, and this is the whole of the solenoid. Now the magnetic field at the end of a solenoid is given by B and equal to half of this value, and its proof is you have to read in higher class. But मन रखिता magnetic induction at the end of the solenoid will be half of its magnetic strength. The magnetic field the magnetic field inside the solenoid is uniform magnetic field. ई भितर कौन होची तो lines of force का जेहेतु parallel होची all are uniform, but outside it is non-uniform, and the magnetic field outside a very long solenoid is very weak. Inside outside lamba solenoid very weak fiber, and it may very weak and can be neglected, and it may be 0 also. So dear my students, this finished your magnetic field due to a straight solenoid, and which is the application of Ampere's circuital law. Thank you.